Let's go on now to example number 7. And in this example, we're still going to be completing the square, and our a term is still going to be 1. The only difference now with these examples that I want to show you is our middle term happens to be an odd number. And that kind of throws in a little loop now, because when we divide by 2 and square it, it's not going to be a nice number, a whole number. It's going to be a fraction. And so, lovely fractions, we all love those, right? Oh yes, our best little friend, BFFs. But I just want to go and show you a few here. I'm going to do a 7a and a 7b example, just two examples that have an odd number. But we're still doing when a is 1. And then in example 8, I'll show you what happens when a is not 1. Okay, so let's tackle this guy, and let's do this. Okay, so of course, we're going to complete the square, and it's in the form of ax squared plus bx plus c equals 0. See, blah, 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 blah. Write the squared term as a is 1. So a is already 1. That's nice. So that means step 1 is good. Bing! Step 2, write the equation so it looks like this. The x squared term and the x term are on the same side, and the c is on the right side. So the x squared and the x term are on the same side, so that means we have to move this negative 1 to the right. All right? So we'll go ahead and add the 1 to both sides. So that means we have x squared plus 3x equals 1. Bing! That was step number 2. Step 3 requires to take our b term, cut it in half, and square it. So here we go. This is where it's going to get a little tracalia. So take 3 and divide it by 2. Okay. Now for this sake here, now you can use a calculator and get a decimal. I'm going to leave it in rational form, and it's more than likely that your quizzes and your assessments are going to want it in rational form. Rational is a fancy word of saying in fractional form. So we're actually going to leave it like this. So when I say cut 3 in half, this means 3 halves. Means I just cut 3 in half. All right. So this is cutting it in half, and now we have to square this. So squaring a fraction means I square the top and I square the bottom. So square 3, I get 9. Square 2, and I get 4. Okay, and this is called our special number. I'll put a little star right there. My stars are kind of funky looking. Oh well. All right, so this is our special number there. So that's step number 3. Bing! Step 4, I want you to add this special number to both the left and the right side. All right? So let's see, x squared plus 3x plus 9/4 equals 1 plus 9/4. All right, so let me just highlight what I just did. I just added 9/4 to both sides. See that there? So this is what we had in step 3, and then in step 4 we added this special number 9/4 to both sides. Okay. All right. So now step 4 is to wait, we just did step 4. That's because we forgot to do the little bing. All right. Step 5. We're going to factor the left side and simplify the right. So this was why the little shortcut is extremely important, because trying to factor this may be a little hectic. Meaning if you're going to try to do the little judo X and put a 9/4 on top and then put a 3 on the bottom, so you're looking for two numbers that multiply and give you 9/4 and two numbers that add to give you 3. It may take you a while to find those two numbers, but as I said, the shortcut is I just take this middle number and I divide it by 2. So it's x plus 3/2 squared. Okay, it will always factor like this: x plus something squared or x minus something squared. And that something can always be generated by looking at your b term, our middle term, and dividing that by 2. Always like it's cool. Yeah. Okay, but now we have to simplify 1 plus 9/4. All right. Change the black here. So just remember, when we add two numbers, one of them being a fraction, we have to get a common denominator. So the common denominator of 1 and 4 is 4. So I'm going to multiply this top and bottom by 4. And so now you see they both have a common denominator. Cool. So it's over 4. And 9 plus 4, 13/4. Okay. So that's step 5. Bing! Step number 6, solve the equation. All right, well, it's the same steps we've always done now. To get rid of the square by doing the square roots. Okay, so I have x plus 3 halves. Again, the square crosses out with the square root there. Equals plus or minus, notice what I'm going to do here now. The square root of 13 all over 2. Notice that I only put the radical with the 13, but the radical did not go with the 2 now because I took the square root of 4. Okay? The square root of 4 is 2, but we can't simplify the square root of 13, so I'm just going to leave it as radical 13. Okay? All right, and then we're going to go ahead and subtract 3 halves from both sides because I want to solve for x. I'm going to subtract 3 halves from both sides. So 3 halves cross out right there. So x equals, we always put a constant number first, negative 3 halves plus or minus radical 13 over 2. Now notice that they both have the same denominator, so we don't need to try to multiply and get a common denominator. So let's just write this as one statement then, as just saying negative 3 plus or minus radical 13 all over our common denominator of 2. And this would be our nice answer right here. Well, I'm trying to pause, or I'm trying to stop the video, but it's not letting me. Maybe we can make this a longer video for kicks. Okay, there it is.